This Late Night Linux Family podcast is made possible by our patrons. Go to latenightlinux.com/support for details of how you can join them. Support us on Patreon for access to ad-free episodes and early releases. That's latenightlinux.com/support.
Hybrid Cloud Show, episode 44. I'm Aaron.
I'm Gary.
I'm Sean.
And I'm Shane.
Welcome to the show about public cloud, private cloud, and everything in between. Our views here are ours and not those of our employers. So recently we've seen outages both at AWS and Azure. Does someone want to give me a quick rundown of the AWS outage, just so we can think of the wider implications of that?
Sure. So a software bug, I think in AWS DynamoDB's DNS automation system in US East 1 caused an empty DNS record to propagate, and that broke name resolution for DynamoDB, which would already be a significant impact to customers using that. But also many AWS services rely on DynamoDB, and that cascaded into control plane failures in US East 1, with also some impact globally as well.
Okay, and that global impact, was that just people who only had things deployed in US East, or are you meaning global in the sense that it affected people who were across regions as well?
Reports are inconsistent, but it seems like people were having control plane issues outside of US East 1. I think this comes down to some of the architecture we can dig into in AWS that's led to some dependencies on US East 1 that might surprise people.
According to Amazon's own documentation, a lot of the control planes for some services like IAM, organizations, account management, that kind of stuff, are all in US East 1, but the data plane for all of them exists in the other regions. That's kind of how they architected that scale.
Okay, so practically what does that mean for people who have deployed things in multiple regions?
It effectively means that a lot of the regions are read-only in terms of getting state out from them, and you can only make changes if US East 1 is available. So if you take IAM as an example of that, you would absolutely be able to get lists of users and authenticate against the EU West 1 endpoint, but you wouldn't be able to do things like create new users, get a new access key, update an IAM policy if US East 1 were to be unavailable. And AWS actually have a really useful white paper that we can link in the documentation about where their fault isolation boundaries are and how some of this stuff works internally. But effectively, there are 4 concepts to bear in mind. There is an AWS partition, which is either the public AWS partition, the US government cloud AWS partition, or the China AWS partition. And you can think of those as literally separate AWSs for those 3 purposes. They can't talk to each other. In most cases, support people won't have access to different partitions other than the one that they work in. It is effectively another instance of AWS. And then in terms of services within those are defined as 3 separate types. You have zonal services, which may have a control or data plane per availability zone. You have regional services, which will have a control plane and data plane per region. And then you have global services, like Sean mentioned. IAM is one of those, where it has a global data plane, as in each region has its own data plane. So things like user accounts which only should exist in a certain region, or pieces of personal information that should only exist in a certain region, only exist there. But the control plane for IAM is only in US East 1.
So if US East 1 goes down, that means we can't make IAM changes in US West 2, EU East 1, any of them, right?
Yeah, that's right. And AWS in the guidance actually specifically say that if you want clean recovery from this kind of failure, you shouldn't depend on any control plane action for IAM.
Interesting. Huh. How do you go about doing that? How do you go about making IAM changes that aren't dependent on IAM?
Well, you effectively make sure that you have the users and keys and access that you need provisioned ahead of time, assuming that you won't be able to have write or change access to IAM in the event of a failure. And it's all about really defining the failure modes, right? This probably isn't something that most people considered, which is why it had such wide-reaching consequences, and indeed isn't something that a lot of the AWS service teams considered, because DynamoDB is a really strongly consistent key-value database, and therefore its API being available is something that most people assumed would be a thing, and it's not a failure mode people planned for. Something like IAM you can plan around a bit more easily by having something like DR users available that you can log into and break glass points and things.
Does this effectively mean that because some of these services are global and not available across multiple regions, that you can't really have a truly highly available service on AWS that doesn't have a dependency on US East being up?
You can certainly architect around some of these limitations. I mean, AWS have a bunch of guidance on how they think you might do that, but there are always going to be edge cases, right? And in this case, we met one of those edge cases, which was someone at AWS fat-fingering a DNS record. It's an interesting question. Is it possible to have globally resilient architecture anywhere? The answer is probably no. But certainly on AWS, for a bunch of the core services, IAM being the one that we keep pointing at, but there are a whole bunch of others that they list. Among those are things like Route 53, S3, CloudFront. There's a whole bunch of them, STS being another one, that are in this failure mode where there is a dependency on US East 1. So could you build around it? Absolutely. Should you spend your time trying to do that, knowing that AWS's strategy is to have that level of availability in US East 1 and that this kind of outage only happens very rarely? Probably not something you want to spend engineering hours on, if I'm being honest.
Yeah, I'm actually just even looking at the AWS S3 control plane operations. There's specifically certain operations that are dependent on US East 1 and then others that aren't. And trying to imagine an application where you're like, I won't depend on these operations for S3, but I will for these because I know that these operations can be done regionally. I mean, you're really building a product around your cloud provider then.
Yeah, and I think it's probably worth mentioning that the whole reason that this exists is because US East 1 was the first and only region at AWS when some of these older services were designed. And therefore, things like a globally available control plane just weren't thought about back then.
Perhaps this is just me and old, ancient, out-of-date wisdom, but I was always told don't deploy production workloads in US East 1. Does that still hold true, or is it kind of irrelevant, considering everything, like lots of things are dependent on US East 1?
I mean, I think it depends. So we're talking about a very specific set of services and control plane calls that are dependent on US East 1. So for failure modes like this, I think maybe you are better off deploying elsewhere because you would still have, like you said, Shane, those other operations that would be available to you, not that you're particularly designing around them. I guess the other thing is that US East 1 is the default region when you create an AWS account. It is therefore the biggest region. It historically, although increasingly less so, is the region where certain services or certain pieces of hardware get deployed first. So there are pros and cons to that, right? If you want the newest AWS models for some of the Gen AI services, they're only going to be available in US East 1. There are also a whole bunch of services like Alexa for business and things like that that also only exist in US East 1. So you might be bound to it in that case. You might prefer to use it because you want the new shiny stuff in dev, for example. So maybe you stick your dev environment in US East 1. But I still think that that conventional wisdom of put production elsewhere is quite valid. And indeed, if you look at AWS's pricing model for network ingress egress across regions, there is only one region which has free ingress and egress from another region, and that is US East 1 and US East 2. I will let you make your own decisions as to why there might be free network ingress egress between those two regions.
So where does that get us? If you're someone who is looking at this and saying, or let's be honest, if you're someone who's in charge of the infrastructure and you now have someone from your C-suite or somebody, who's read about this in the newspapers and wondered why everything went down, and they're saying to you, how do we prevent against this sort of thing? What's the answer?
Well, I think I'm going to be the pessimistic person and say, if you're deploying in AWS, there will always be, or at least in its current state, some dependency on US East 1, whether you like it or not. And that goes for even if I'm just deploying EC2 on AWS, because again, certain IAM actions will depend on US East 1. So therefore something like assuming a role as an instance might be dependent on US East 1, depending on what it is that you're assuming. So I think it's actually really difficult in AWS to not have some dependency somewhere on US East 1. S3, like Shane said, there are a bunch of actions that will be dependent on US East 1 control plane being up. And that is just the way it is. Now, of course, that doesn't discount that AWS are working on this. There are a bunch of services that have had certain control plane actions broken out. There are certain services, notably some of the newer ones, that have those regional or zonal control planes and data planes, but those are generally not the core AWS services because they're the older ones that were built when there were fewer regions.
Okay, so we've talked in the past about the challenges with building things in a truly multi-cloud way, or the compromises that you have to make to build something in a way that is not linked to a particular cloud provider, maybe by doing it in a hybrid environment or, as I say, across different clouds. So if somebody is trying to make that choice, they are effectively making the choice of simplicity, knowing that there are failure modes they just can't prevent against in that way of working.
Yeah, like Gary said, trying to figure out a way to have a globally, DR, I can withstand an asteroid hitting me is next to impossible. And if your whole entire cloud goes down, right, if all of AWS goes down, what are you going to do? If you can't even change your Route 53 address to point at somewhere else, another cloud, what are you going to do?
Change your name server?
You can change your name server, but then that's not really easy to do depending on your domain and how locked down that is. Got to have somebody come off their yacht to go change off one thing because they're the one who has access to that, right? That's not always so easy to do. It's what your fail modes are.
Does it make any of you think that for those particular services, we should think about using other third parties to do those same services, or are they really things that are just too core to try and work around?
I do wonder if a lot of them are just reselling AWS infrastructure with another layer, to be honest. So unless I had some confidence that they would handle a global outage better than Amazon, it's tricky.
And if you're in charge of infrastructure at your company, then you're paid to know that. Does Cloudflare's name server also live in AWS? You should know that.
Well, and I think it's a level deeper than that, right? Not only should you know that, but you should also know where these fault isolation boundaries are in AWS and encourage your application teams to build around them. Like, I know that's really hard and that you're never going to get 100% of the way there. But where possible, you need to understand what those failure modes are and where your dependencies are. I mean, I used an example earlier of making sure that you had a break glass user provisioned just for this. And it is your job as someone running the infrastructure at your company to have that provisioned, have the break glass procedures in place in order to get the double knock, triple knock, director's signature, keys to the safe, whatever it is that you need to go and get those credentials. Because if you don't have that, then you have effectively said, that's not a failure mode I care about. I don't care if IAM's down.
Can you talk me through that break glass thing? Because I've heard the term before, I've seen it done in some organizations, but given we're mentioning it, can we explain that to the audience?
So a break glass user is one that basically has the keys to the kingdom, that it has permissions to all the services, it has root access, and the only person who can access this is usually, like he said, has, the director under lock and key in his file cabinet, and you have to actually break out the piece of paper to be able to type in the manual password to get in. But you do that and make it so complicated because they have the keys to the kingdom. You don't want just anybody be able to OAuth into that.
It's sometimes like the kind of credential that you'd hold in escrow if you were working with a partner, right? And where it comes from is the fire alarm. You don't go and break that glass on the fire alarm and evacuate the building unless you are really, really confident there's a fire and you need to go and break the glass on the fire alarm. So that credential exists. You never use it. You make sure it's enabled. Maybe you test it every now and again, but it is specifically there to have local access to an account to log in and perform actions in an emergency scenario. Say, IAM is down, or you suspect that the partner running your infrastructure is doing something dodgy and you need to kick them out. Those kinds of scenarios where you just need to get in as root and you need it now.
And presumably when you do that, there should be alerts going off and all the rest to let you know if somebody else is doing that when they shouldn't be.
Yeah, you should be using CloudTrail or something like that, sending alerts to your security team, fully expecting the CISO to be calling you, asking what the hell you're doing, all of those things, right? But this is, again, like going and pressing the fire alarm. It's panic stations. Everybody needs to know about it.
And you would use this break glass permission or break glass identity when IAM goes down because that root user doesn't depend on IAM because basically they're just God mode and don't need to ask for permissions for anything.
They already have them.
This isn't some kind of user that you have in AWS organizations that has federated access into a bunch of accounts. This is local God mode root user in the account as a general rule.
Gotcha. No, I've created lots of accounts and had lots of root users, but it was more I did not realize it didn't depend on IAM. That's good to know, actually.
It's not that it doesn't depend on IAM, it's that IAM has already given that user all the permissions they need.
Right.
So you don't have to make any changes in the middle of a DR event.
Yeah. No, I got it.
Yeah, you're not calling the IAM control plane to go and make changes to, or even request, does this user have permissions to shut down this EC2 instance? Don't care. It's God. It can do whatever the hell it likes.
Right.
And equally, you might have one of these break glass users to go and provision a bunch of infrastructure in a cold standby or a warm standby account or something. It is just there to give you access to the account or an account to go and do what you need to do. And there are a bunch of different recommendations that AWS have around what they call static stability of applications. But really, AWS's definition of static stability is that systems being able to operate as if nothing had happened, if a dependency is unavailable. So what AWS tend to strive for all of their internal applications is this level of static stability. Clearly, in this case, there was a hole found in that model because a bunch of them were dependent on DynamoDB being available. But it's a concept that they really try and follow in how they design their services. So statically stable service is kind of self-dependent and doesn't need to call out to anything to continue normal operation.
Right, so it keeps going as it was going, but you can't make any changes to it.
Yeah, exactly.
I'm thinking more about application teams now. If, let's say, I was on EKS and the whole cluster went down, right, and I need to now move over to another cluster, it can still be EKS, but like in another region, right? Something like that. How would we go about doing that? I mean, let's say the infrastructure team spins up a whole entire new cluster. Is there a way to easily just DR and move all those workloads over? Or would each application team then have to go and try to grab their databases and move them over, grab their applications, grab their state, and move it over to this new EKS cluster?
State and data are going to be your biggest blocker because maybe that's a massive database that has very live data. You need to get the most latest copy of it. I think that depending on your engineering rigor, if you've got CI/CD pipelines and they're configurable, it might be as simple as changing some credentials and changing a region and everything just spins up. But data's always going to be a scary one.
Well, again, I think it depends on what your failure mode is, right? Have you architected the application or have you educated your developers on what those particular API calls they may or may not be able to make are? Have you architected around that? Have you actually accepted as a business that you are beholden to certain failures in the AWS control plane and that actually you can tolerate certain outages in certain scenarios? I mean, that's the most common one, right? Is that actually you just go, well, AWS IAM is down. Therefore, this instance can't assume a role. That means it can't do X, Y, Z. And therefore, this certain subcomponent of our application is there that isn't going to work properly. There's a whole bunch of ways to approach this that aren't just change the region flag in my CI/CD pipeline and go and redeploy.
Yeah, this touches on like application design as well. Like if you're basically doing DR with your application, maybe you're testing out like I'll run this application and workload in a different region. However, if the code itself is making calls to an endpoint that you don't know is single region, say one of those particular S3 endpoints that's US East available, then the DR exercise to some extent, if that's a critical part of your workflow, that DR exercise is kind of pointless. It doesn't matter what region you're in. Your production path as a single point of failure. So that's kind of an interesting thing to have to think about from an app perspective.
So Shane, you're trying to build platforms for developers to use, right?
Yeah.
And I sort of look at this and I think this is that challenge where you start separating out the layers, and you've got people who know stuff about clouds, or they know stuff about particular clouds, and then you've got developers, and you're trying to abstract away those developers with platforms so that they can code against platforms without having to worry about the cloud-specific stuff. Is there a way that you can help or make those API calls more noted or changed or something? How do you solve this problem when you've got those different layers and different teams?
It's a really difficult problem because essentially you're trying to limit engineers in what they can do in their code. I guess you could prevent it with if you are aware of all the single points of failure endpoints, we'll say in AWS, you could say, okay, any application user who's going to run this app in the cloud will not have access to these endpoints. Probably, though, if I'm going to think about a platform, the platform will be whatever, you'll be given some ability to configure your service, and that'll spin up the infrastructure needed. But also you may need to write code that interacts with that same control plane. Perhaps what we could do is create an internal library that abstracts away the cloud to some extent. So if we decide we're going to change IAM provider, or we're going to try change our storage provider, that might be a transparent operation to the end users. You're trying to think about almost SDKs for your company in interacting with cloud providers. That's potentially a way around that. And one way I've tried it, because if you start with that principle, it's not painful to then roll that out later on. Let's say you decide, okay, we're going to use SQS and SNS as a way of messaging in our application, and we decide to change that to Event Bridge. That's a nightmare if everyone's written hard-coded API calls to SQS and SNS. But if that's abstracted to the message bus system in our company, then that becomes a much less miserable rollout. So this, I think, might be another benefit of doing something like that, where you learn things like, hey, we're all dependent on these weird S3 calls in EUS1. Let's whittle down that API layer we're giving.
And of course, the cloud providers will give you a slightly different answer, right? Which is to not couple your application to being able to make that call right now. Do something like queue it for later, or retry, or exponentially back off if it's going to be a gray failure in one of those endpoints, for example. It's a little bit less black and white than it might seem. If in your example, Shane, we were writing to our message queuing system, what we might actually do is abstract that away, but have a way that we know that we've accepted that message somewhere, we've written it somewhere, and it gets written to an event bus later on. So we're almost queuing writes to an event bus if the event bus isn't available, which sounds a little bit weird, and it doesn't quite work in that example. But it's that kind of thinking of really loosely coupling applications and working out, well, what do I do if this thing isn't available? And starting to ask those questions as and when you come up with these things in RCAs, right? So in this example, we might have discovered that DynamoDB was unavailable. And because our application couldn't write to a DynamoDB table now, things fell over. Well, okay, how do we work around that? What do we do if DynamoDB isn't available? Do we write to some kind of middle tier that then queues it for a write to more persistent storage later? And you can end up with some really complex architectures by doing it that way. And it's that real balance between architectural complexity and resilience that I think it's all of our jobs to try and walk, isn't it?
I'm trying to think how you could even test for this. Could you put something in your CI/CD pipelines where you somehow replicate this to try and get to that, what was the term you used, the sort of steady state that doesn't take any changes but continues to be stable? It'd be really interesting if there was a way you could effectively test whether you could survive an outage of US East 1 without your infrastructure failing over.
Well, you could do it by writing an IAM rule in AWS that basically denies anything create, read, update, delete on any US East 1 endpoint. There's a bunch of chaos engineering you could do around it. And AWS has stuff like Fault Injection Simulator that will do some of this. But what is quite difficult to simulate are those gray failures.
It seems we're doing our name a disservice by kind of saying that if one cloud goes down, then you're kind of just doomed depending on how it goes down. I mean, is there a hybrid cloud solution that we could suggest, or areas worth exploring to see if someone could get around this outage?
Absolutely. The question is, what is your failure mode? Just like Gary said, how much are you willing to spend to survive US East 1 going down?
Let's pretend I've got infinite budget and time.
All right, one fancy land. Then, as an application developer, just thinking basics. The first thing that I would want to do is make sure that my database, my state, my Redis cache, my S3 bucket, whatever it is going to be able to survive one of these clouds going down. And you have a couple options there. You can either A, find some way using some sort of automation to keep multiple buckets in sync, because there's no native way to just say like, hey, AWS S3 bucket, now also mirror this GCP bucket. Like, there's no native way to do that. But you could do that if maybe you had something like Minio in the middle that could talk to both these clouds and maybe even a third on-prem version and keep these things in sync for you. Maybe you don't have the latest millisecond, but down to the minute, that would be pretty good. Databases is a much more complex topic. I'm not sure. There are some globally available ones that they survive a region going down. In GCP, I think it's called Spanner.
I feel like in that scenario, certainly your S3 one, you're ignoring the slight £10,000 gorilla in the room, that you could build some kind of data replication engine that would be more available and resilient than an AWS region and a service that offers like 9 nines of durability in terms of data. So are you moving the fault isolation boundary somewhere else and making it your problem rather than Amazon's problem in that scenario?
That's right. And I don't have to beat 5 nines of uptime. I just have to just be up when Amazon is down and just have that data available to someone else. That's the only failure mode I care about. So yes, it is kind of moving the goalposts, but in this case, I would have survived S3 being down and had my data available somewhere else to then spin up a new workload on it.
When we've talked about this before, I think when we're advising people who are effectively targeting a single cloud, then where we often land is that the complexity of trying to take your architecture that's designed for a single cloud and go through the various hoops to try and make that multi-cloud or hybrid cloud, that's quite a hard problem, or it's quite a lot of extra cost. It feels a bit different if you are doing a hybrid cloud deployment and you're having to solve all of these problems to do things across both your on-premise infrastructure and, well, I say on-premise, I mean like, hosted data centers or on-premise or whatever, non-cloud, non-public cloud, and doing that across into the public clouds as well. I feel like there you're having to be a bit more cloud neutral anyway in your architecture, and there it's easier to try and resolve some of these problems without dependencies on specific services from individual clouds.
Yes, it's easier to solve a hybrid cloud problem when you went into your architecture with that mindset. If you're already using tools that were cloud agnostic and keeping you away, that's perfect. But then you're not able to take advantages of the clouds and what they offer. And that's kind of the goal, right? To take the best of both worlds.
Well, on that beautifully inconclusive answer, it's perhaps time for us all to call it a day. Before we do, just a quick thank you to those people who support us on Patreon or PayPal. If you'd like to send us your questions or feedback, you can to show@hybridcloudshow.com. We'll be back in 2 weeks. Until then, I've been Aaron.
I've been Gary.
I've been Sean.
And I've been Shane.
See you later.